Okay, for today, I shall be focusing on a very important topic in C Sharp, trees. And in this, I would want to mention it succinctly that in for trees in C Sharp, we have binary trees, binary search trees, and balanced binary search trees. Now, for this particular video, I shall be addressing this question to describe a recursive function that accepts a valid binary tree and determine if it is a binary search tree. Before I go further, my name is Gabriel Chikwandonwofoke, a student of software development at BYU-Idaho. Now to the question of the day, there are three ways I'm going to address this: the overall approach, the base case, and then the recursive case. Now from the first part, the overall approach. Since the BST, when I mean BST, I mean the binary search tree. Since the BST must hold at every single node, not just at the root, I will traverse every node recursively while passing down a valid minimum and maximum boundary that each node's value must fall within. At the root, there are no boundaries yet, but as we move left, the current node becomes the new maximum, and as we move right, the current node becomes the new minimum. Now to the base case. If the current node is null, we have reached the end of the branch with no violations found. We return true because an empty subtree is always valid. Now to the third part, which is the recursive case. At each node, I first check whether the node's value falls within the allowed minimum and maximum range. If it does not, I immediately return false. This tree is not a valid BST. But if it does fall within the range, then I make two recursive calls. The left subtree is called with the same minimum, but the current node's value as the new maximum. The right subtree is called with the current node's value as the new minimum, but the same maximum. The function only returns true if both recursive calls return true. In summary, the base case handles null nodes by returning true, while the recursive case validates each node against its boundaries and recurses on both subtrees with updated boundaries. This runs in O of n time since every node is visited exactly once. Thank you for your time.